So now let's talk about magnitude. The magnitude of a vector is its length, okay? So again, this is the same picture we've seen before, right? A at the bottom, or X is our horizontal distance, Y is our vertical distance. So if I wanted to find the length of this vector, what would I use? If I want the hypotenuse, I would use Pythagorean theorem, right? So it's the square root of x squared plus y squared. So if you want to think about it as if it's written, if your vector's written in AI plus BJ form, these bars here, kind of like absolute value bars, that's our notation for magnitude. So that's what tells you that you're finding the magnitude. So if it's written in AI plus BJ form, it would be the square root of a squared plus b squared. And if it's written in component form, that's xy, it's the square root of x squared plus y squared. You might see the magnitude also written like this with 2 bars. I don't believe Alex ever writes it like that, but if you ever see something like that, maybe in a physics class or something, that's what it means, the same thing. Some people just use a different notation there. Okay, so we're going to find the magnitude of the vector. They want us to write it in simplified radical form. So the magnitude of vector v here is the square root of -6 squared is 36. -2 squared is 4. So that's the square root of 40. And we want simplified radical form, so we want to pull out any perfect squares. Remember, 40 is 4 times 10, right? The square root of 4 is 2, so 2 root 10. Everybody okay? I told you it was easy, right? Okay, so let's talk about this vector that says 2j. So which direction does that vector travel, horizontal or vertical? Vertical, right? I is horizontal, J is vertical, right? X, Y, A, B, it's all alphabetical order, right? So that means this is the vector that doesn't travel horizontally at all. It travels only up 2 units, correct? So it's the same thing as saying that that vector is 0i plus 2j. Now, we, of course, wouldn't write that because why bother, way too many pen strokes. But I just want to be sure you understand what that means. That means that vector doesn't travel horizontally at all. It just goes up 2 units. And it would be the same thing as in component form, 0, 2, right? Make sense? So if I want to know how long that vector is, isn't it just 2? Right? It's just going up 2 units. I can do the Pythagorean theorem. Square root of 0 plus 4 is the square root of 4, which is 2, right? But understanding what that is makes it a little different. All right, so now the only difference is they're giving me my vector in component form rather than the AI plus BJ form. So we're going to do the same thing. I'm going to just say magnitude instead of writing out, well, actually, I'm just going to say mag because I'm lazy. And we're going to have the square root of 2 squared is 4 plus 36. Same thing. That's nice. Which is the square root of 40. 40 is 4 times 10, so 2 root 10. And then we have the vector -4, 3. So the magnitude is the square root of 16 plus 9, which is the square root of 25, which is 5. Now, usually when we do square root, we would pull out a plus or minus, right? But we're talking about a length, so that's why we're not worrying about the negative part of it, right? We can't have a negative length. And also here, you could have just already said 5, right? If you recognize the Pythagorean triple there, you wouldn't have to do the Pythagorean theorem.